Welcome to all. In this session, I am going to explain the example number 7. So, in biomedical engineering branch, for the lab 20EC407L integrated electronics lab. So, example number is design and implementation of code converter such as BCD to excess-3 code and vice versa. So, first one is BCD to excess-3 conversion. Second one is excess-3 to BCD conversion. So components and equipments required for this experiment is XOR gate IC7486 number 1 and AND gate IC7408 one number, OR gate IC7432 one IC, NOT gate IC7404 IC 1. So IC trainer kit and patch code. So this is the components required for this experiment. So first I am going to explain the BCD input into excess-3 conversion. So this is 4-bit BCD number. So highest value is B3, B2, B1, B0. So this is 4-bit input, our BCD input. So we want to convert into excess-3 output. So G3, G2, G1, G0 is the excess-3 output. So BCD means, so for example, the BCD weightage is 0 means, so we want to convert excess-3 code, we want to add plus 3 with the BCD, given BCD number. Here 0, 0, 0, 0 means, so we want to add 3, that is 0, 0, 1, 1 with the our BCD input. So we are getting the excess-3 output. Similarly, next input is 0, 0, 0, 1 means, so we are going to add plus 3 with the BCD input. So here output is 4, 0, 1, 0, 0. So this is the combination of 8, 4, 2, 1 code. So our output is 4. If you give the input as 1 means output is 4. So for every input, so we want to add plus 3 for getting the excess-3 output. So next case is 0, 0, 1, 0. So that is, so weightage is 2. So 2 plus 3 is 5 here. So 0, that is 1 means, that is 4 value 4 and plus 1, 4 plus 1, 5. So if you give the input is 2 means 2 plus 3, 5. So similarly, for this case, so input is 1, 0, 0, 1. So that is the weightage is 8 plus 1. So total value is 9. So for the BCD input 0 to 9, so we are getting the output in the excess-3 code. So 9 plus 3 means 12. This is 8 plus 4, 12. So totally, so we are getting the 12. So input is 9 means output is 12. So every conditions we are going to add the 3 for the, add the 3 input for the 3 input. So next, so if the value exceed the above 9, so that is 1, 0, 1, 0 means, so our excess-3 output will be in the don't care conditions. So we are, so only going to convert from the BCD input 0 to 9, we are getting the excess-3 output. So for input is 9 means excess-3 output is 12. So we are adding the plus 3 with the BCD input. So this is the logic diagram for BCD to excess-3 converter. Here we have the 4 input B0, B1, B2, B3. So we want to get the 4 output, that is E3, E2, E1, E0. So for calculating our for calculating purpose, we are going to use the KMF to find the expression for the output E3, E2, E1, E0. So this is the logic diagram. So based on the our input is given. So this is the KMF for output expression E3. So here input is B3, B2 is input and also B1, B0 is the input. For in this case, so we are getting the, after calculating the KMF, so E3 is equal to B3 plus B2 into B0 plus B1. So B0 and B1 is the AND operation, addition operation, that is OR gate. So with B2 is multiplied, so we are using the both this combination for OR gate plus one more addition will be used. So this is expression for E3. So similarly for calculating the E2 expression is E2 is equal to B2 exclusive OR into B1 plus B0. So next is, so KMF for E1. From this KMF calculation, E1 is equal to B1 exclusive complement of B0. So similarly E naught is equal to B naught bar. So for getting the output expressions we are using the KMF. So now based on this expression value we are going to design the logic diagram. So this is the logic diagram. For this case, for addition operations, I am using the OR gate 7432. So under multiplication operation 7408 and XOR gate 7486 is used. So under for inversion operation 7404 is used. Based on the our expression E3 is equal to B3 plus B2 into B1 plus B0. So based on this expression, I am going to connect this logic diagram. So the input is one of the input is taken from B3. So B3 is given to the pin number 5. So next, so another combination is B2 into B1 plus B2. So B1 is given to the OR gate pin number 1. B0 is given to pin number 2. So output is 3. You are getting the pin number 3. So that output is given to the X7408 pin number 1. And one more input is given to the B2 is given to the pin number 2. So finally we get the output in pin number 3, that is given to the OR gate for pin number 4, and B3 also applied the pin number 4. Finally we get the output E3 in pin number 6. So similarly for E2, so we want to use the B1 plus B2 XOR gate and B2. So B1 B2 is getting the output here, B1 B0 getting the output here, and one more input is so B2. So finally it gives the output like this: E2 is equal to B2 XOR into B1 plus B0. So next output is B1 XOR exclusive or complement B0. So in this case we are using the XOR gate and one NOT gate. So next fourth output is E naught is equal to B naught dash. So in this case, so one inverter is, that is 7404 used for the getting the output. So finally based on the our KMF expressions, we design the excess-3 BCD to excess-3 converter logic diagram. Now I am going to implement this. So BCD to excess-3 converter into digital trainer kit. So these are my input B3, B2, B1, B0. So this is our output E3, E2, E1, E0. So in this case, so I am going to use IC7432 and IC7404 and IC7408. So for in this experiment I am using the IC7432, 7408 and 7486 for the XOR purpose and 7404. So as per the logic diagram all the connections are made. So 14th pin is VCC, 7th pin is ground for all the ICs. So depends upon logic diagram we are giving the input. So we want to verify the truth table. So our input is, so this is our input is 0 0 0 0 means all the values are 0. So I am getting the output E3 is equal to 0, E2 is equal to 0, E1 is equal to 1 and E0 is 1. So here input is 0, here input is, that is output is 3. So 0 0 1 1, that is output is 3. For next case I am going to give the input for, so last one is, that is B0 is equal to 1. So if you apply the value is 1 means our output is 4. So 0 1, that is 1 means this is 8421 code, that is output is 4. If you apply the input 1, so output is 4. It will be converted in the excess-3 format. So 0 4 0 0. So next case is, so input is, we are giving the input is 3. So here input is 3 1 1, that is 0 0 1 1, input is 3. Here output is 6. Sorry, input is 3 means here input is 3. So output is like this. So 1 0 0 1, like this. So next is input is, there is 0 1 0 0, that is input is 4 means output is 4 plus 3 7. 4 plus 2 6 plus 1 7. So 3 is the input, 6 is 7 is the output. So next case is, so 5 means if you give the input as 5 means, so that is 5 plus 3 is 8. So 1 0 0 0. So last case I am going to verify the, so for the input is 9. So So this is input is 8 and 9. So 8, if the input is 8 means output is 12. Sorry, output is, sorry, input is 9 means 8 plus 1 9. Input is 9 means 9 plus 3 is 12. So this is 8 weightage, this is 4 weightage. So 8 plus 4 is 12. So if the input is 9, output is 12. So for this case, so we verified the BCD to excess-3 conversion. So with the help of digital trainer kit, if you apply the input 0 means output is 3. So every operations we are going to add plus 3 with the BCD number, that will be output of the excess-3 coder. So next I am going to explain the excess-3 to BCD output conversion. So here input is excess-3 code. So the 4 bit E3, E2, E1, E0. So we are going to convert this excess-3 number into BCD, B3, B2, B1, B0. So this is also output also 4 bit. So in this case, so I am going to give the first input is 0, 0, 1, 1. That is, so this is 8, 4, 3, 2, 8, 4, 3, 1. So 8, 4, 2, 1 combination. So total weightage is, so 2 plus 1 3. So weightage is totally, we are giving the input is 3 means, so in this excess-3 to BCD conversion, so we want to subtract number 3 from the excess-3 input. So here is input is 3 means 3 minus 3. So we are getting the output is 0, 0, 0, 0, 0. For next case, if you give the input is 0, 1, 0, 0, that is input is 4 means 4 minus 3, that is equal to 1. So 0, 0, 0, 1. So that is our output. Next is input is 5 means 0, 1, 0, 1. So input is 5. So 5 minus 3 is equal to 2. So 0, 0, 1, 0. So this weightage is 2. So next input is 0, 1, 1, 0. That is input is 6 means 6 minus 3, that is equal to 3. So output is 0. BCD number is 0, 0, 1, 0. This is 2 plus 1. 2 plus 1, 3. So if you give the input 6 means output is 1. So for last case, so if you give the input is, so 1, 1, 0, 0. So 8 plus 4, 12. If you give the input 12 means 12 minus 3, I am getting the output 1, 0, 0, 1. So this is 8 weightage, this is 1. So 8 plus 1, 9. If you give the 12 input, so I am getting the output is, BC number is 9. So for this purpose, so we want to subtract the, so excess-3 number with, so 3. So 12 input means 12 minus 3, that is 9 is the output. So based on this, so input, so I am getting the logic diagram. So here input is E3, E2, E1, E0 is the input. So similarly output is binary number, that is BCD number B3, B2, B1, B0. So for obtaining this output expression, so I am going to calculate the, going to do the KMAP calculation. So this is the KMF for excess-3 to BCD conversion. So these are the expression for E3 based on the, after completing the KMF expression, B3 is equal to E3 into E2 plus E1 into E0. So E3 into E2 plus E1 into E0. So for B2 expression is E2 XOR into E1 bar plus E0 bar. This provides the addition operation. So this is provide the XOR operation. So for this operation, we for the XOR gate and AND gate. So next came for B1. So our output expression is B1 is equal to E1 XOR E0. So we are using the one XOR gate for this purpose. So next is output is B0. So B0 is equal to E0 bar. So in this purpose we are using for the NOT gate. So based on our output expression obtained from the KMAP calculation, so I am going to draw the logic diagram. So this is the logic diagram. So B3 output is E3 into E2 plus E1 and E0. So in this case, so E1 input is given to the one AND gate 7408 pin number 1, E0 is given to pin number 2, so output is taken from pin number 3. So this output is given to the 7432 XOR gate, that is OR gate input of pin number 2, and one more input is given to the OR gate from the E2. So one input is E2, so another input is from the output of the AND gate. So this is given to the, so AND gate pin number 5, output is 3 is given to AND gate pin number 5, and E3 is given to the pin number 4. So finally we get the expression of output based on the output pin number 6. So B3 is equal to E3 into E2 plus E1 into E0. So next case, so we want to draw the logic diagram for B2. B2 is equal to X2 XOR into E1 bar plus E0 for. So first we want to use the 2 NOT gate for the inversion operation of E1 and E0 bar. So output is pin number 2 E1 bar, here E0 for, that output is given to the OR gate. Pin number 4 and 5 is the input, 6 is the output. This combines this combination, so we are getting the output E1 bar plus E0 bar. So finally 6 is the output of this OR gate, that is given to the one XOR gate. So one more input for the this expression is E2. E2 is directly going to give the pin number 2 of XOR gate. So 1, 2 is the input, 3 is the output. So we are getting the output E2 XOR into E1 plus E0. So next, so B1 expression. So B1 as per the truth table, B1 is equal to E1 XOR B. So in this case I am going to use the one XOR gate. So pin number 4 is given to, so E1 supply is given to pin number 4, E0 is given to pin number 5. So this is XOR gate, they perform the operation E1 XOR E0. So last output is B0. So B0 is equal to E0 bar. So here we are getting the E0 value. So NOT gate output 4 is given to the, so B0, that is equal to E0 bar. So based on this logic diagram, so we design the output expressions. B3 equal to E3 into E2 plus E1 into E0. B2 is equal to E2 XOR into E1 bar plus E2 bar E0 bar. So B1 is equal to E1 plus E0 XOR gate, B0 equal to E0 bar. Now I am going to implement the excess-3 to BCD conversion in the digital trainer kit. So here, so I am using the input port. So this is the input. So E3, E2, E1, E0 is the input. So next is output is B3, B2, P1, B0 is the output. This is our output. For this experiment, as per the logic diagram, so we have to use the IC 7486 for XOR operations, and 7408 for AND operation, 7432 for the OR operation, and NOT gate used for the inversion operations. So 4 ICs we are using here. So all the connections are made as per the logic diagram. So now I am going to apply the input. So for the excess-3 input, the first case input is 0, 0, 0, 0, 1, 1. That is first input is, we are giving the excess-3 input is 0 means, so this perform the subtraction operation with number 3. So if your input is 0 means, input is 3 means 3 minus 3 minus 3 is equal to 0. So give me the excess-3 input 3. So our output is 0, 0, 0, 0. So perform the 3 minus 3, excess-3, 3 minus 3. So answer is 0. So next input is, so if input is 4 means, so this is input 4 means 4 minus 3, 1. So input is, I am giving the input 0, 1, 0, 0. So input is 4. So output is 0, 0, 0, 1. So total value is 1. If you give the input 4 means 4 minus 3, 1. So next is input is 5 means, so I am getting the output 5 minus 3, that is 2 is the output. 8, 4, 2, 1 code. So 2 is the output. So next if you give the input is 6 means, So input is 6. So 6 minus 3, that is output is 3. 2 plus 1 3. So next input is 7 means, so input is 7. So output is 4 0 1 0 0. Input is 7, output is 4. Next input is 8 means, so I am giving the input is 8 means, so 8 minus 3, that is 5. So this is 4 value and plus 1. 4 plus 1 is 5. So input is 9 means, so 9 minus 3 is equal to 6. So 4 plus 2 6. So input is 10 means, so input is 10 means, so that is 8 0, sorry 1 0 0 1 means, so I am getting the output is, so 0 1 1 1. So next input is, I am giving the input 1 1 0 0. So that is, so 8 plus 4 12 is the input. I am getting the output 9 minus 3 is the, so input is 8 plus 4 12. So 12 minus 3 is equal to 9. 9 is the output. 8 plus 1. So based on this, so experiment verified the truth table of, so excess 3 input to BCD output using logic diagram. Thank you.